To make use of the MEC APIs, I've prepared a local edge cloud environment on a standard laptop where you'll see an example of an HTML-based client instance interacting with a locally hosted server. This environment is simple to set up, where I'll show you the steps. First, how to set up the server stub that exposes the APIs. Then add connectivity from that to a database that contains the information to expose. Finally, how to query for and present information from these APIs via your MEC applications. The first port of call is the ETSI's Forge site, where all the MEC applications are provided using the OpenAPI specification. Here, the MEC API of interest can be selected. In this case, we're going to look at the Location API. So we click on the Location API link, and this takes us to the repository. This uses GitLab. Here, issues and bugs can be raised and the OpenAPI description evolution with each MEC specification release examined. The specific version associated with the MEC specification release is also tagged for convenience. The OpenAPI description for each API is provided in both YAML and JSON. As part of the commit procedure for a new version, a linter is used to analyze the description to flag syntactical and stylistic errors. We need to scroll down this page and we get to Edit API Online. And we click this and it takes it to the ETSI hosted Swagger editor. And this is a great way to explore the API endpoints and supported HTTP methods as well as the data model. And this can be seen over on the right hand side with each of the HTTP methods and the associated endpoints. It also allows the generation of both server and client stubs, which is what of most interest in this demo. To generate a server, select Generate Server, as highlighted here, and your preferred language, Node.js for this demo. This downloads a server stub, which allows local testing of a server generated using the OpenAPI description. However, it should be noted that the generated API code contains just the stub methods. That is to say, there will be minimal actual MEC service logic, with certain language options. Example responses are provided, and those are provided to the client following a request once the server is up and running. Therefore, developers need to implement the logic themselves in order to handle whatever function the work of the API needs to do. An example of such logic will be presented here using example user location samples based on the Monaco Formula 1 Grand Prix circuit. So once downloaded, place in the desired directory, as seen here. So this is the local directory on my machine. And then these files can be viewed and edited in your favorite IDE, where in this demo, I'll be using Microsoft Visual Code. So picking out some of the key files. First of all, we look at package.json. Here I've added support for CORS. CORS stands for Cross-Origin Resource Sharing. This allows requests to be fulfilled when the requested resource has a different origin, e.g. domain, protocol, and port. This allows the client and server to communicate and exchange content. CORS support is also added to the index.js file. Here you'll also see the port the server will be assigned to. So in here, 881. Now if we look at some of the actual logic, so if we look in the user service.js file, we can see exports users get, which aligns to the get method applied to the Location API's users endpoint, and in this instance queried using a zone ID. And here I've just highlighted that, and we can see the example response, which is in JSON. And we can see the user address, access point ID, zone ID, and the resource where that user is linked to. The other example is user specific, where user location is recovered using the user ID. Here I've implemented the server logic to connect to a MongoDB database, and this is highlighted here. When a get user by ID request is made, the MongoDB is queried for the next stored location. The longitude and latitude in the example API JSON response are replaced with the values returned from the database. These are then sent to the client in the query response. Before the server can run, MongoDB needs to be installed, and in this instance, the location server DB database created with a locations collection. Here I'm showing the Mongo Compass community tool with all of the locations listed, with one specific highlighted in main view. So, we've added the server code and we've created the database with its collection. We can return to the command line, and here we can use the npm start command, and this has been executed and it shows that the server has been successfully started. A nice feature of the servers is that it hosts the API description using the Swagger UI tool. This means the server API can be explored like we also saw with the Swagger editor. Now for the client. Here I'm using an HTML web page which uses JavaScript to make location API queries. First I've installed Swagger.js from the Swagger team, which is an open source JavaScript library to connect to Swagger-enabled APIs via a browser. The functionality can be utilized in an HTML file to interact with the server, for instance to query for a user's location. I've also used Leaflet.js, which is the JavaScript library for generating interactive maps viewable through a web browser. Now we can see the actual requests, so get users by ID again, and then the call to plot the location. So once these edits have been made, we can actually load the HTML page and invoke the query. This plots a recovered user's location on a map and also gives you the specific coordinates. With each click, additional locations are plotted until we see the full Monaco Grand Prix circuit highlighted. So in this webinar, I've given a quick overview of using one of the MEC APIs, namely the Location API. I presented both a server and a client, where the server exposed location information for a specific user, and the client presented that information via a web page on a map. This demonstrates that setting up an environment to explore the capabilities of MEC APIs is reasonably straightforward, and this therefore allows software developers to focus on the important task of creating new and innovative edge-based applications utilizing the standardized MEC APIs. So what are you waiting for? To provide a motivation, the first step might be to enter the upcoming MEC Hackathon. Here, once you've entered the competition, you will receive all the necessary instructions for developing and running your applications at the edge. We look forward to your application.